Hi, welcome to FarnetPy videos. This is DC here. In this video, I'm going to show you how the interrupt works in PN5180 board. This video will be an overview, and this is purely from the point of view of the software developer. And if you're a hardware designer, you have to read the documentation for more information. So you have to refer to the datasheet, and there is a nice explanation on how the interrupt works. So there are a couple of bits here as well as some bits in the later part of the document. Now I'll be giving a very general overview of what the interrupt, how the interrupt works, and how to program with this interrupt. There is one pin which is called as IRQ pin, which is available in the board, as well as this is also available in the connectors. You can connect directly to the Arduino to listen to this interrupt. There are nearly 15 different types of interrupts, and in general, the interrupt tells that certain event has happened within the chip, and this event is known to the outside world through this IRQ pin. Now all these 15 interrupts are routed through a single pin, that's IRQ pin. So you have to keep one thing in mind, because there are more than one interrupts and just one pin, and this happens like a many-to-one relationship. So if you receive, or if the Arduino receives an interrupt signal, so you have to find out how many interrupts have appeared. So for that, there are many interrupt related registers. There is a register called IRQ status register, and the next is IRQ enable register, and there is one memory called IRQ pin config memory in the EEPROM. So all these three entities are related to the interrupts. So this is the summary of what I just mentioned. Now you got this PN5180 chip. This is the IRQ pin. There's only one pin, and this can be connected to Arduino, and this represent all the interrupts that chip can generate, and these interrupts are routed to the IRQ pin. Now there is a feature where you can decide which interrupts you would like to route to the IRQ pin. So there are, say, 16 interrupts, so your software may be interested in just 2 interrupts you would like to know on the interrupt line, so you can just enable those interrupts. So this enabling and disabling, it's all to do with whether the interrupts are routed to this IRQ pin. It's nothing to do with, you cannot control or you cannot stop the interrupt from happening, so you have to keep this in mind. And this is the interrupt status register. Now any interrupts that have happened within the chip is available for us to read, and there is a command to clear this register as well. So when you clear the status register, so the signal in the IRQ pin will also get stopped. So this is what you want to know about the interrupt related registers and commands. So as I mentioned before, the IRQ status register, this is a 32-bit register, out of which only the 16 bits are used. So this tells us how many interrupts are raised within the chip. So you can read the register and find out which interrupts are triggered. Now IRQ enable register, using this register you can decide which interrupts you want to route it to the IRQ pin. So every interrupt has got a corresponding bit. You can either set to enable or set to 0 to disable. The IRQ clear register, so this is meant to clear the IRQ status register. Now the way this whole interrupt routing works is, so assume that there are 3 interrupts that are raised within the system, and because of that the IRQ pin is set to high. So all the 3 interrupts are set to 1. So if I just go and clear one of the interrupt, you still have 2 interrupts that are set. So because of these interrupts, the IRQ pin is still active. Now the IRQ pin signal will be removed only when all these interrupt status are cleared. So that's the reason why you use this IRQ clear register. There are some interrupts which you cannot control the routing at all. Say there is an interrupt called general failure. So whenever the general failure happens, it's always routed to the IRQ pin. You cannot control that. There are 3 interrupts in general. I would advise you to see the datasheet. So there is also one memory in the EEPROM memory called IRQ pin config. If you read the page 48, so here this is the EEPROM address 1A. So here you can find how to clear this interrupt status register, and also you can control whether the IRQ signal you want that to go low or you want that to go high. So as well as how do you want the interrupt clear to work, whether you want all the interrupts to clear as soon as the IRQ status register is read, or the clear can happen only by writing to the IRQ clear register. So these 2 configurations you have to now get used to that. So using my software, you can play with this whole configuration and you can get more knowledge. So back in the software, the version of software is 1.2. Couple of new things have gone in the software. Say for example, if you look at the release notes, so the full functionality for Mifare Ultralight Tag has been added. Now I'll be making a video on this in the near future. So we are going to see this interrupt. So I'm connected to my board. If you click on the console, the first thing is you have to get familiarized yourself with all the registers I mentioned about. Now this is the IRQ enable register. Now this is the initial state of this. So it says the idle IRQ is enabled by default, and the next one is IRQ status register. So this tells you all the interrupts that are happen in the system. Next one is the IRQ clear register. Now keep in mind, IRQ status is a read-only register, you can't write it. So if you want to clear the status, you have to use the IRQ clear register, which you can clear by writing all FFs or writing the bit 1 to clear the corresponding IRQ. And also in the EEPROM side, I mentioned about this IRQ pin config. It is a 1 byte, and you can write something here to decide to configure whether the IRQ is cleared automatically, or whether you want the IRQ pin signal to be logic 0 or logic 1. So what I'm going to do is, I'm not going to control IRQ enable. I'm not going to do anything. So I'm going to keep this default. So I'm going to turn on the RF. So the RF is on. Now if you go back to the registers and read the IRQ status register, you can see that the bit corresponding to RF on is set. So this indicates there is an interrupt. This also tells you that the RF energy is on the board. If you try to read again, now you can see that this RF, the entire status is automatically cleared. This is because of the value that is set in this. So this is as soon as you read the value of IRQ status register, the status is cleared. So likewise, I can try with RF off. If you go back to the register and read, so you can see that the corresponding RF off bit is set to set, and if you read again, it's gone. Now this time I'm going to execute an invalid instruction. Say for example, in the commands tab, go to read register. I'm going to try to read a register that is 90, which we know it's not a valid register. If you see this drop down list, this is all the valid registers. So I'm going to forcibly send an invalid read register command. So execute. Now the software just returns a random 4 bytes. However, when you go to the registers here and look at the IRQ status register and read, you can see that the general error IRQ status is set. So the next thing I'm going to try is I'm going to activate an ultralight tag. So before that, I'm going to set the RF on and activate this type A. You can see that the tag is activated. Now if you go and look at the status now, you can see so many interrupts that happen. So one is the RF is on, and it's also now the CPU is idle, and also it says the TX, there is some transmission happen, there is some reception has happened, and also this RX SOIF, that's start of the frame, has been detected. So again, you have to read go to internet and get more information on that. The datasheet doesn't give any more information than what I mentioned here. Some of these interrupts are pretty straightforward. Now RX means there is some data coming from the tag, and TX means some command has been transmitted from the chip. And so likewise, once you understand this concept, you just have to scale this by reading more and more information from internet. If you try to read this again, now as you can see, everything is gone. Okay. So next, I cannot demonstrate the working of IRQ enable because this feature controls whether the interrupts are routed through the IRQ pin. The only way you can find this working is by connecting the IRQ pin. If you look at the connectors here, so there is a IRQ pin available here. So you just have to connect this to one of the digital input, and this is something if you have worked with Arduino, this is a very simple exercise you might have tried, that is listening to an interrupt and linking that to an interrupt handler. However, in order to control, you just have to go and just set it. For example, I would like to route only this, maybe RF on, RF off, and something, maybe I would like to route only these interrupts to the IRQ pin. Just select that and write it. Now you can see that if you read, you can see the bits are set correctly. So with this, what we are trying to say here is only these interrupts are routed to the IRQ pin. Keep in mind, this is not, you're not controlling whether to raise the interrupt or not to raise. Interrupts are always raised by the chip. This controls whether these interrupts are propagated to the outside world through the IRQ pin. The next thing you can try is to set the IRQ pin config data in the EEPROM. If you click on the EEPROM and select this line here, so the default is 0, 0, 0. So if you want to set the voltage on the IRQ pin, so if you just have to look in this documentation. Now it is this one you can try. Now somewhere now something is not very clear from this documentation. It says, so this is 1 byte and this is the bit 0 to 7. So I presume this is bit 0. If it's cleared, you get active low on the IRQ pin. If it is set to 1, you get active high. And if it this is for pin number 1, that's the second bit. Sorry, it's bit 1, that's the second bit. If it is clear, it says use IRQ clear to clear the IRQ pin. So this is like manually clearing all the interrupt flags. If it is set to 1, it says it's auto clears on read of the IRQ status. So as soon as you read the IRQ status, all these flags are cleared. Now somehow what I could not demonstrate is what we have seen just now. As soon as I read the IRQ status register, all these flags are cleared. I don't know where in the system you can control that. So that's something you have to probably explore, or you might get that information from the PN5180 forum. So we're going to try again. Before I finish this video, I'm going to have the RF on, and I'm going to activate a Mifare Ultralight tag, and I'm going to read starting from block 0, and I'm going to say all the interrupts that are raised. If you go to IRQ status register, it's a read. Now you can see that the start of the frame is been detected, and the RF on is being detected, plus there was some transmission and reception, and probably this idle IRQ, probably this indicates that the PN5180 chip is idle, is ready to receive the next command. Now if you have written any embedded program, probably you will be using this IRQ clear register to clear the bits. So I'm going to just show you how the clear register will work. Assume that I want to clear this and that, these two interrupts. As soon as you click, you will start getting the bit mask, and you write it. Now if you try to read, read will always give me a clear register, because as soon as you read this once, all these flags are gone. Okay, I think that's all. It's a very short video compared to all my previous videos, and I hope you understood this concept of interrupts. Thanks for watching.